0.634 centimeters per second. Good. So a couple of important things to note when you're writing your explanations is to make sure you include, like on average, you include the time interval, right? If you say decreasing, do we put negative on the rate? No. Okay, so a couple of things to make sure that you're careful on, right? When you're doing instantaneous, you want to make sure that it's specifically at that particular moment in time, right? And again, watch out for your decreasing and your negative. Don't make that mistake. Make sure you include the units. Pretty good? All right, we're almost done, okay? We'll get through this page and then we'll be finished, okay? Sounds good? They never said anything?
We never hang up.
Crazy, right? Maybe they were trying to call me. My daughter. Oh, I guess my wife took care of it. Alright, so let's see how a function and its first and second derivative are related to regarding position, velocity, and acceleration. So, when I had my original function, what would that correspond to here? That would correspond to position, right? And yes? That would be like P of t or what? S of t or X of t, right? The different notations that they use to represent position. When I get the first derivative of my function, that would correspond to what? Velocity, right? Which would be v of t, right? Or it could also be what? P prime of t or S prime of t or X prime of t. With me? When I find the second derivative, that corresponds to what? Acceleration. So that would be A of t or P double prime of t or S double prime of t or X double prime of t or V prime of t. Yes? Maybe? Alright. We good? We're still awake?
Yeah.
No? You don't like this?
I like it.
Position, velocity, acceleration? Not really? I'm sorry. Yes.
Doesn't that say that the position, the acceleration says the position changing at an increase in velocity? Yeah, but that's what the velocity is. But we do know.
No, how to figure out speed. He told us it's like that was speed, this y'all should get on a cigar. I was
The rate of the position is changing.
No, that would be velocity.
You gotta get here on time.
Yeah, like it says the velocity is increasing.
I know.
That's what.
Only if you're
So
so
it's
other
actually
guy.
like a block shoe.
Right? But that's what velocity is.
I need bread.
So it's saying.
Oh, I see. Because I went like this and like my finger went like this.
Yeah, but the rate at which it's changing is either increasing or decreasing. The rate at which it's changing.
Yes.
No, like, oh, it's just in there.
The rate at which the.
The rate at which the position is changing,
Yeah.
which is velocity.
Velocity.
The rate at which the velocity is changing.
Because we can just say velocity.
Yes.
Like, so the particle would be the rate at which it's Rate at which the particle position is changing.
Which is the same thing as saying the rate at which the velocity.
That's what I was trying. Yeah, it's redundant because you can say velocity.
Yes. Good? But if you wanted to put it in terms of position,
No, but the position, like the rate at which it's changing. Not the position. The rate at which it's changing. Yeah, I know, I agree with that. But the rate at which it's changing.
the rate at which the position,
What are you gonna do?
the rate at which the rate, not the position.
Oh, yeah, that's what you originally said, yeah. Yeah, no, I
You need to respond to the rate.
Yeah, no, the rate, it's what the original was.
So the rate of change of velocity was the rate of the rate of change of position.
Oh, yeah, we did.
Alright, anyway, okay, so you got a little mental break, we had a cool discussion over here, but anyways, let's come back to this. So, let's see how velocity and position are related. Alright, we know velocity is v of t, it's also the same thing as the what of the position function. The first derivative of it, right?
Yes.
Alright, so what does the first derivative tell us about something? It tells us where it's increasing, decreasing, or relative maximums or minimums, alright? Now here we're talking about the position of a particle. So we don't want to say where the position is increasing or decreasing, but we rather want to say where the position, or where the particle is moving to the left or to the right, okay? So that's what we're going to say instead of increasing or decreasing. What do you think we're going to say when we have a relative max or a relative min? It changes direction. So is it going to change from going to the left to going to the right, or going from the right to going to the left? Either or? Okay, cool. Alright, so what does it mean when the velocity is equal to 0 or undefined? That's where we said we could have a potential relative max or min. So this could technically, in this case, mean it's a potential what?
Change direction.
Okay, so could I say a potential turning point?
Yes.
Yes? The particle could change direction? We would need further investigation to determine if it did, right? That's where the sign line comes into play. And if we do the velocity sign line, which is the first derivative sign line, and you see that the velocity changes from negative to positive, then you know for sure that it is a turning point, because the particle then went from moving to the right to moving to the left, or vice versa. Do you understand? Yes? But at this point, it's only a potential turning point. Alright, if the velocity is greater than 0, meaning that it was positive, what would that mean about the position of the object? Very good. So moving to the right. If the velocity was negative, then the particle would move to the left. If the velocity changes from positive to negative, then the particle changes
From right to left.
very good. The particle moves from right to left. And in order to do that, what does the velocity have to be at that moment where it switches?
0.
0, right? The only way I can go from moving from the right to the left is that my velocity becomes what? 0 at that split moment in time.
Excuse me, Mr. Science.
Yes, ma'am.
You have Isabella Garcia in class.
Yes, I do.
When the bell rings, sir, can you please knock it?
Okay.
Thank you.
All right. What if the velocity changes from negative to positive?
Left to right.
Pretty easy. It won't ask you to relate acceleration to position, because like we were saying, it gets redundant and it's a little hard to compare. Most of the time on the AP test, they'll give you the velocity function, because that one you can use to relate to acceleration or to relate to the position. Just like when I did on my problems with the graphs. I gave you the first derivative graph, and I asked you about the second derivative, and I also asked you about the original functions. The same idea, except now we're not talking about just functions and what's happening on the graphs, we're actually talking about something real. Okay? So what could we say if the acceleration was equal to 0? What would we have? We could have constant velocity, right? Or what else could happen? There could be a potential what? Change in velocity. So let's say you were on the highway, right? And you were in drive because you're going forward, right? And you're going 75 miles per hour, right? But you want to change your velocity, so that means you want to not only change your velocity, but you want to change the direction as well, right? So you're 75 miles an hour and then boom, pop it in reverse, right?
Oh yeah, you just.
So
Yeah, you
but you just want to change direction, right?
Yeah, but he said.
So you destroy the transmission, right? So don't try that at home, alright?
Now you tell me.
At that moment, the acceleration will be 0, because you're not accelerating anymore. Going in the opposite direction. Potential change in velocity. Good.
Literally like your car died. Your car died.
If acceleration is positive, what does that mean about velocity? Velocity is increasing, so this one we'll just say like that. If the acceleration is negative, then velocity is decreasing. Does that mean you're moving in the opposite direction?
Nope.
No, it just it could mean that you're moving in the same direction, you're just not moving
As fast.
as fast, right? Cool?
Yeah.
What happens if the acceleration changes from positive to negative? Velocity changes from what? And if the acceleration changes from negative to positive? Changes from decreasing to increase. You understand? Then you get into the point of speeding up and slowing down. Have you guys talked about that? How would I determine whether a particle is speeding up or slowing down?
If it's slowing
Speeding
down.
up. So that would be like I'm moving in this direction at some velocity. How could I speed up? I would have to accelerate,
Yeah.
but I would have to accelerate in the same direction, right?
Yeah.
Yes? So like Anthony, come up here, right? Stand right there. Okay? And you're gonna help me accelerate. So I'm walking and then help me accelerate.
Hey.
So,
On the camera.
you saw that? So he helped me accelerate because he was pushing me in the same direction, right? So now stand up again, Anthony.
Oh my god.
Turn around this
Way
side.
back, revenge.
No, turn around this way.
Oh.
Okay? So now I'm traveling at a velocity, right? In this direction. But now he's gonna be going this way, so what's he doing? So now am I speeding up or am I slowing down when he was? Right, okay, because the acceleration was negative. You understand?
Yeah.
Yes? So in order for a particle to speed up, the velocity and the acceleration have to be the same what?
Sign.
The same sign, right? And they have to be being pushed in the same direction. Could they both be negative? Yes, that would be that I would be moving to the left and then I'm being pushed to the left. Okay, so it's gonna speed me up. We got it? Yes? Alright, so for homework. Okay, I want want you to work on this one right here. What do they tell us that this graph represents?
That's gonna be pleasing.
This represents the position S of t of a particle which is moving along the x-axis. Okay, so we have a couple of minutes left if you want to look at it, but I know that I've been talking for a while, so you're probably tired. You can work on that for homework. You can study for your quiz, okay?
Say what?